Hello, welcome to Math 251, Calculus 1 here at Cañada College. My name is Lapuz and I'm the instructor for the course. In this video, we will be taking a look at an overview of section 2.4, Continuity. 2.4 begins with a set of criteria for us to find out whether a function is continuous or not. We want to make sure that the function is defined at the point. If it's not defined, then the function doesn't even cross that point. We have to make sure that the limit exists. If the limit does not exist, then it's possible that coming from the left and coming from the right will give you two different values, and then you'll have to make a jump. And then finally, we have to make sure that the limit matches where the function is defined. So if any of these fail, then we have a function that's not continuous or discontinuous. And we can classify the discontinuous functions by seeing which of these three criteria it is failing on. And so in the case where the limit does not exist, that could be case 2, where you have a jump discontinuity or infinite discontinuity. Or maybe there's just a hole in the graph. And if there is a hole in the graph, you can think about it as a removable discontinuity. The case that we see here for A, the removable discontinuity, you have a point that's actually defined, but it's not defined where the limit is. And so in that case, we can see that the limits criteria that we had says that the function is defined and the limit exists, but the third criteria was not satisfied, and then that they're not equal to each other. So we have a removable discontinuity if your function simply has a hole in the graph. You have a jump discontinuity if you come from one side and coming from the other side you have two different limits. In this case, the limit does not exist. So whether or not A is defined, in this case, in the second graph over here, A is defined, but whether or not A is defined, if your limit does not exist because of a jump discontinuity, then your function is not continuous. And then finally, we're going to run into a lot of infinite discontinuities as well. And so in those cases, your function's not continuous. One of the important results of having a continuous function allows us to use what's called the intermediate value theorem. The intermediate value theorem requires you to start off with a continuous function. And what it's saying is that if you have a number z, for example, a y value of z, and then between a and b, when you put a into the function and b into the function, then those values are on opposite sides of z, then it has to eventually cross through z at some point within your interval. Now this is used a lot for finding roots of something. If you remember, roots are when the function set equal to 0. So you can imagine like your z value being 0, and then if you have a number that you put into the function, you get a negative, and another number you put into the function, you get a positive. Then if the function is continuous, at some point between those 2 points you'll have to cross the x-axis. So this is your intermediate value theorem, sometimes called the IVT. That's your quick overview of section 2.4. Okay, good luck.